Welcome to the Explainer. So if you've been anywhere near cloud computing lately, you've definitely bumped into the absolute backbone of modern software deployment. Today, we're totally breaking down the two most critical tools driving the whole industry forward, Docker and Kubernetes.
And the big question we're answering today is what exactly makes Docker and Kubernetes the most popular tools in the cloud? I mean, we hear these terms constantly, right? But today we're going to strip away all that jargon and reveal exactly why they function as the ultimate power couple.
Here's our roadmap for today. We'll be covering cloud computing essentials, Docker and containers explained, Kubernetes, the orchestrator, combining Docker and Kubernetes, and wrap up with some real-world examples and best practices. Let's dive right in.
Section 1. Cloud Computing Essentials. Okay, before we get into the tools themselves, let's set the stage. In this massive, rapidly expanding cloud universe, you really need a way to deploy applications so they work perfectly every single time, no matter where they're running. And you know, that's the exact problem Docker and Kubernetes were built to solve. They literally take the guesswork out of deployment to give you true, unbreakable consistency.
Moving right along to Section 2, Docker and Containers Explained.
So to really get Docker, we first have to talk about containerization. Think of it as a platform that lets you package, ship, and run your applications in these lightweight, virtual machine-like containers. For us developers, this is an absolute silver bullet for that infamous, well, it works on my machine problem. The container packs up the code and all its dependencies, so it runs exactly the same whether it's on your laptop, a testing server, or a production cloud environment. It's a total game changer.
Now, Docker's architecture relies on this highly efficient pipeline. Step 1 is all about developer intent. The Docker client sends your commands. Then step 2 is execution. This is where the Docker daemon steps in and does the heavy lifting, actively managing and running those containers. And finally, step 3 is the blueprint. The daemon pulls exactly what it needs from the Docker registry, which securely stores all your images. Pretty straightforward, right?
Which brings us to Section 3, Kubernetes, the orchestrator.
If Docker creates the packages, Kubernetes is basically the warehouse manager. Fundamentally, it's an orchestration platform that automates the deployment, scaling, and management of all those containers. Fun fact, Kubernetes was originally designed by engineers over at Google simply because humans literally cannot manually manage millions of containers. It was built from the ground up for massive automated scale. To actually handle that kind of scale, Kubernetes uses a very specific anatomy of resilience. Right at the top, you've got the cluster. That's your big picture environment. Inside the cluster are your nodes, which are the actual physical or virtual machines doing the real work. Digging a little deeper, we find pods. These act as the logical hosts. And then, nestled securely right inside those pods are the containers themselves. It's just like a set of perfectly organized nesting dolls.
Now, this whole complex hierarchy exists to enable three incredibly powerful features. First up is self-healing. If a container crashes, and let's be real, they sometimes do, Kubernetes instantly restarts it without the end user ever noticing a single hiccup. Second is resource management, which ensures optimal performance for every single app. And third is automated scaling, so you can seamlessly handle massive, unexpected traffic spikes, no sweat.
All right, Section 4, combining Docker and Kubernetes.
So the division of labor between these two is very distinct, but man, is it entirely complementary. Docker creates the container. Kubernetes commands the container. Docker's only job is strictly to package and ship applications consistently. Kubernetes' job, on the other hand, is to deploy, manage, and scale those applications completely automatically. When you put them together, they just offer the ultimate peace of mind. Docker guarantees your app runs the exact same way in production as it did in development. Meanwhile, Kubernetes guarantees that if a server completely goes down, your app will self-heal and instantly spin back up somewhere else. It's literally a fail-safe combination designed specifically to keep your infrastructure online.
And finally, Section 5, Examples and Best Practices.
Let's connect all these concepts back to your actual day-to-day operations. Say you're building a web app with a load balancer. The best practice approach here is to use Docker Compose to clearly define your containers right up front. Now, if you're working with a complex microservices architecture, you're definitely going to want to rely heavily on Kubernetes to seamlessly deploy and manage those independent services. And for debugging, ditch the guesswork entirely and just leverage Kubernetes' robust built-in monitoring and logging tools.
Well, we've covered the cloud essentials, the detailed architectures, and the undeniably amazing synergy between these two platforms. So I'm going to leave you with this final thought. What applications will you containerize and orchestrate next in your own cloud infrastructure? I mean, the tools are right there, ready for you.
Thanks for joining me for this explainer, and happy building.